Okay, welcome back. Here are a couple of examples of finding absolute extrema on the indicated interval. So the first one here is on the left. We have a simple polynomial quadratic function. We want to find the absolute extrema on the interval 1 to 2. So we're still looking at kind of a small area of the graph. So the first thing we do is find critical points by finding the derivative, which I've already done for us. And we set that derivative equal to 0 and solve that to find out that we have a critical point at 3/2. Then what we have to do is evaluate the function, the original function, at the critical point, so f of 3/2, and also at the endpoints of the interval itself. So we also have to do f of 1 and f of 2. And you can see that I've done those evaluations here. And so here's what I get. I have 2, 1, and 2. So I have a couple of things going on. I have an absolute minimum of 1, that's the smallest number there, at x equals 3/2. And we have absolute maxima of 2 at x equals 1 and at 2. Okay. So there's what our answer will look like. Okay. All right, next I've got another function over here. A little bit more complicated function. So we have f of x equals x squared plus x to the 2/3 power. We're looking at the interval from -2 to 3. So we would need to first find critical points for this one. In order to do that, we need the derivative. And in the interest of time, because of the video issues, I'm going to just tell you what that derivative is. I am relatively confident that you all know how to find derivatives. So it would look like this. 2 times 2x plus 1 over 3 times x squared plus x to the 1/3 power. Okay. Then we would need to find critical points. Now in this case, we're actually going to find critical points when the top is equal to 0 and also when the bottom is equal to 0, which is a little bit different. So we'll start with the top. We have 2x plus 1 could equal 0. Okay. On the bottom, it's interesting because even though I have this power 1/3 and I'm multiplying by 3, I really just have to focus on this middle part, right? Because if it's 0, 0 to the 1/3 power is 0, and 3 times 0 is still 0. So I really just have to focus on x squared plus x equals 0. When I solve this, I'm going to get x equals -1/2. When I solve this, I'm going to end up with x equals 0 or -1. Okay? And even though the derivative does not exist for these values of 0 and -1, right? If this is 0 and -1, we can't evaluate that. That gives us something that's undefined. The original function is defined at x equals 0 and -1, so we have to actually test all of these points. We have to test the two endpoints, -2 and 3. We have to test -1/2, 0, and -1. Now, again, in the interest of time, I'm going to kind of just run through some of these, knowing that you all know how to evaluate functions. So there are all the evaluations that we need to do. Keep in mind, when we do this, we're going back to the original function to evaluate. And we're going to need to use the calculator here and maybe get a few approximations. 1.58, 0.396, ... 5.24, ... This is going to be 0, and this is also going to be 0. So here's what's going to happen. Again, I'm going to look at all of these values. The highest value, which is at f of 3, is going to be where we have an absolute maximum. This is a 5.24 at x equals 3. The lowest values we have are actually 0. So we actually have an absolute minimum of 0 at x equals 0 and x equals -1. Okay. So we've just done a couple of problems where we are finding the absolute maxima and absolute minima on a closed interval. Okay. All right, this is a good stopping point. Again, so we're going to have, I don't know, this may turn into like 4 videos or something. So we're going to talk about some more absolute extrema in a moment.